Dear students, let us derive more dimensional formula. So, let us take relative density. Relative density. So, the formula for relative density is relative, that is density of substance upon density of water. So density upon density means it's a pure ratio, so it will have no dimension. So dimension will be m0, l0, t0. Now we can go for work. So work done is F into D. That means the dimensions of force m1 l1 t minus 2 into distance, that is L. So the dimension formula for work done or work is m1 l2 t minus 2. So will be the dimension formula of the energy. Energy, that is work is equal to energy. So W equal to E. That's why the units of the work and energy are same, that is joule. So the dimension formula for energy is also m1 l2 t minus 2. Now if we try to find out the dimension formula of the torque. So what is the formula for the torque? In class 11th we will study in later chapters. So torque is force into force arm. That means again the same thing is here, F into D or F into R is same. So the dimension formula for torque is also m1 l2 t minus 2. Now we can go for the power. This P equals to work upon time. Rate of doing work is the power. Rate of doing work is the power. So to find the dimensional formula of a physical quantity, we need the for dimensional formula of physical quantity, we need so power is work upon time, that is rate of doing work. So as far as the dimensional formula is concerned, it is very easy to derive if you remember the formulas. So be well versed with the formulas and then you will not have any problem. So work upon time. So work is m1 L2 t minus 2 divided by time. That means m1 L2 t minus 2 divided by time. So you will get m1 L2 t minus 3. m1 L2 and t minus 1 and minus 2 and minus 1 is minus 3. So the power is m1 L2 t minus 3. What about the stress? Stress is again force upon area, and force upon area is pressure. So try to relate formulas. So you will get very easily. So force upon area is pressure. Pressure is force is m1 l1 t minus 2 and divided by area, so it will be minus 1 t minus 2. So this is the dimensional formula for the stress. Then strain. Strain is again a pure ratio like relative density because it is the change in dimension like length upon change in length, that is original length or original dimension. So that means again it is dimensionless M0, L0, T0. Now the modulus of elasticity, whether it is bulk modulus or Young's modulus, all modulus of elasticity, whether it is Y, K or eta, that will be stress upon strain. Stress upon strain. So it will have the same dimension as that of the stress, because strain has no dimensions. So strain is dimensionless, so it will be the same as stress, that is M1 L minus 1 T minus 2. If it is Young's modulus, that is change in length upon original length, yani longitudinal stress upon longitudinal strain. If it is bulk modulus, then it is volume stress upon volume strain. If it is modulus of rigidity, so it is shearing stress upon shearing strain. So it will all have the same dimension. Now we will have the charge or potential. Potential and the charge. Charge Q equals to I into T. So the potential I into T, that means current and this. So it has M0, L0, T1 and A1. And potential is work per unit charge. So work divided by charge. So the dimension formula for the work is M1 L2 T minus 2, M1 L2 T minus 2 divided by time again here AT. So this will be minus 3 and A minus 1. एक बार फिर से देखेंगे, potential is W by Q. Q is I into T, that means A into T. So here it is, work is M1 L2 T minus 2 divided by A into T. So this M1 as it is, L2 as it is, and T minus 2 minus 1 is minus 3, and then it is ampere minus 1. So it is M1 L2 T minus 3 A minus 1. Now resistance C R equals to V upon I. So the potential is this M1 L2 T minus 3 A minus 1 divided by A. Current is ampere. So here again it will become minus 1. So M1 L2 T minus 3, and here it is minus 1 and minus 1. So A minus 2. So this way the dimension formulas of different physical quantities we have just drawn. वर्क एक बार फिर देख ले, वर्क में क्या आएगा, फोर्स इनटू डिस्प्लेसमेंट है, उसको फोर्स का हो गया m1 l1 t minus 2 और उसको एक लेंथ से मल्टीप्लाई कर देना है, तो देन इट विल बी m1 l2 t minus 2. सिमिलरली विल बी एनर्जी का सेम होगा जो उसका है, इसको चाहे तो यू कैन चेक इट विद द हाफ mv स्क्वायर काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी, दैट विल रिमेन सेम. नाउ टॉर्क इज r cross f, force into force arm, that means it is again force multiplied by the distance, so it will be the same as of the energy. Now we can have power. Power is W by T, that is M1 L2 T minus 2 upon T. So it is M1 L2 and T minus 2 and minus 1, that will be T minus 3. Here stress is force upon area, that is same as that of the pressure. So M1 L minus 1 T minus 2. Strain is dimensionless quantity because it is a pure ratio, change in dimension upon change in original dimension, that is delta L by L, delta V by V. So it is again M0, L0, T0. Now we have the modulus of elasticity, that is stress upon strain. So if it is Y, then it is longitudinal stress upon longitudinal strain. If it is K or B bulk modulus, then it is the volume stress upon volume strain. If it is neta, rigid modulus of rigidity, then that time it will be shearing stress upon shearing strain. So it will be the same as that of the stress. So it will be M1 L minus 1 T minus 2. Now potential. Before finding the potential, we need the dimensions of charge. So charge Q equals to I into T. So M0, L0, T is 1 and A is 1. So then potential will be, that is the electric potential, that V is equal to W upon Q, yani work per unit charge. Then it is work is M1 L2 T minus 2 and divided by charge is A into T1, A1 T1, A1 and T1. So then M1 L2 remains same, so T minus 2 and minus 1 is minus 3 and A comes up, so it is A minus 1. Now we can find the resistance R equals to V by I. So here the potential is M1 L2 T minus 3 A minus 1 divided by A, then A comes out, then it becomes minus, A comes up, so it becomes minus 2. So M1 L2 T minus 3 A minus 2. So be well versed with the different formulas and then you will not have any problem. Now viscosity coefficient. Viscosity coefficient is neta equals to force per unit area per unit velocity gradient. That means force upon area is M1 L minus 1 T minus 2 and velocity gradient is L T minus 1 divided by T. So delta V by delta L or delta X. So L upon T upon L is T minus 1 only. So here we get M1 L minus 1 and T minus 1 is the dimensional formula for viscosity. Now we can have gravitational constant. Gravitational constant capital G, that is equal to, it is universal constant. This G is F into R square upon M square. M1, M2, that means M square. So here force is M1 L1 T minus 2 into L2 divided by M2. So here it will have M minus 1 L3 and T minus 2 which is the dimension formula for gravitational constant. Because according to Newton's law, Newton's gravitational force, F is equal to G M1 M2 upon R square. So G will become F into R square divided by M1 M2, that means M square. So here force is M1 L1 T minus 2 into L2 divided by M square. So here M1 L3 T minus 2, because M1 is 1 minus 2, that is minus 1. Now you can have magnetic or electric field. Electric field E is force per unit charge. So the dimensional formula for the force is M1 L1 T minus 2 divided by charge is A minus 1 and T minus 1 become minus 3. So this is the, you can get it orally, M1 L1 T minus 2 divided by AT. So T minus 3, M1 L1 T minus 3 and A minus 1. Now we can get dipole moment, that is electric dipole moment. Electric dipole moment P is Q into A or 2A, that is distance. So charge into distance. So charge into distance, charge was A and T and distance will be L. So this is M0, L1, A1, T1. फिर से देख लेंगे. This is A and T and distance is L. So here you can have M0, L1, A1, T1. Now we can have a specific resistance. Specific resistance. specific resistance is R equals to rho L by A. So rho equals to R A by L. So you can have specific resistance R A by L. That means R into L. And the resistance was V by I. So V was M1 L1 T minus 3 A minus 1. That was the work upon charge. So work was M1 L2 T minus 3 divided by A minus 1, and here it is being multiplied by L. So here it has to be L3. So this will be resistance minus 2 because A also there. So R into L we have to find. So the resistance was potential divided by current. Potential was M1 L2 T minus 3 A minus 1 divided by A. So this will be minus 2. So M1 L 1L will be there. So L3 T minus 3 and A minus 2. So this is the dimension of specific resistance. Now magnetic field. Magnetic field, that is B. So magnetic field B is F upon IL. Because you have studied in 10th class, force acting on a conductor is ILB. So ILB is equal to F. So you can find B equals to F upon I into L. So F is M1 L1 T minus 2 divided by A into L. So this L will get cancelled out. You will get M1 L0 T minus 2 and A minus 1 will be the magnetic field. Now permittivity, electric permittivity. Permittivity of free space, that is epsilon naught. So that is the electric force is 1 upon 4 pi epsilon naught Q1 Q2 upon R square. So epsilon naught is nothing but Q square upon F into R square. 1 upon 4 pi epsilon naught is equal to F is equal to 1 upon 4 pi epsilon naught. Just see F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. So Q1 Q2 is Q square. This epsilon goes here and F comes down. So this is FR square. You can just, means if you know the formula, then you can get the dimensional formula. So it will be here A square T square divided by M1 L1 T minus 2 and L2. Q is A into T ka square. F is M1 L1 T minus 2 into L power 2. So here we get dimensional formula for the permittivity, that is M minus 1 L minus 3 T4, because minus 2 and plus 2 will be T4 and A square. So magnetic dipole moment, that is M equals to I into A. that is current and area. So area is m0 L square T0 and A is ampere A1. So it is m0 L power 2 T0 A1.